Welcome to The Explainer. Today, we're talking about something that's happening right now in the vast blue parts of our planet, but it's almost completely invisible. It's called ocean acidification, and, well, it's a huge deal. We're going to get into what it is, why it's a crisis, and some of the truly wild ideas being floated to try and fix it.
So let's just start with a number, 30%. Since the Industrial Revolution, the acidity of our oceans has increased by 30%. I mean, just let that sink in for a second. That's a massive, massive chemical change on a global scale. And if 30% doesn't sound like a lot, get this. Scientists are telling us this is happening faster than any other time they can find in the records going back 50 million years. So yeah, this isn't normal. The question is, what is actually going on?
All right, so let's get into the chemistry of it all. We're going to unpack the science behind this pretty dramatic and incredibly fast change. Okay, so at its heart, this is actually pretty simple. You know all that carbon dioxide we pump into the atmosphere from burning fossil fuels? Well, the ocean acts like a giant sponge, and it soaks up about a quarter of it. But it turns out you can't just add all that CO2 to seawater without changing the water itself. Now, here's something that trips a lot of people up. The name acidification makes it sound like the ocean is turning into a giant vat of acid, right? But that's not quite it. The ocean is naturally alkaline with a pH around 8.1. The key word here is the direction of the change. It's becoming less alkaline, and it's moving down the scale toward acidic. And for the creatures that live there, that is a huge, huge problem. And here's how it works in 3 basic steps. 1, CO2 dissolves in the water. 2, it mixes with the water to create carbonic acid. Yeah, a weak acid, but still. And 3, that acid releases hydrogen ions. And those little hydrogen ions, they're the troublemakers. The more of them you have, the more acidic the water gets and the lower the pH goes. This simple reaction is literally rewriting the rules of life in the sea. So, we've got the chemistry. But what does this actually do to the things living in the ocean? Well, this is where we see a massive domino effect, one that ripples out across the entire marine world.
Here is the absolute core of the problem. All those extra hydrogen ions floating around, they gobble up something called carbonate ions. Now, why does that matter? Because for tons of marine animals, carbonate ions are like Lego bricks. They're the essential building blocks they need to build their shells and their skeletons. Ocean acidification is basically stealing their building materials.
And just look at who's on the front lines here. You've got corals, the architects have entire ecosystems. You've got things we love to eat, like oysters, mussels, and crabs. And maybe most important of all, you have plankton. These tiny little organisms are the absolute foundation of, well, pretty much the entire marine food web. If they start to struggle, everybody else is in big trouble.
And make no mistake, this has a huge human price tag. That number you see, $100 billion. That's what experts think the world will lose every single year by 2100, just from the decline of mollusks like oysters and clams. That's not some abstract number. That's people's jobs and food on the table.
And the fallout just keeps spreading. It's way more than just weak shells. We're talking about massive coral bleaching events that wipe out critical habitats. We're looking at major disruptions to the fisheries that feed billions of people. It can even mean less oxygen in the water for fish to breathe. And here's the really scary part. As the ocean gets more acidic, its ability to absorb CO2 goes down. So it actually starts to speed up the very problem that's causing the crisis in the first place. You know, there are other costs too, structural ones. Think about this. Coral reefs act as natural barriers, protecting coastlines from storms. That service they provide for free, it's worth about $9 billion a year. As the reefs die off, that protection just disappears.
Okay, so the problem is enormous. So enormous, in fact, that it's pushing some scientists to think about solutions that sound like they're straight out of science fiction. Ideas for intentionally re-engineering our planet's systems.
Welcome to the world of geoengineering. The basic idea is to deliberately manipulate the Earth's climate to counteract all the changes we've been causing. For some, this is a kind of emergency brake we might need to pull. But for many others, it's terrifyingly controversial because we're talking about messing with the planet's operating system, a system we don't even fully understand. So most of these ideas fall into 2 big categories. The first is solar radiation reduction, or SRR. Think of this as treating a symptom. It's like putting up a giant parasol for the Earth to cool it down, but it doesn't do anything about the CO2 that's already in the air. The other approach is carbon dioxide removal, or CDR. This one tries to tackle the root cause. It's like a giant atmospheric cleanup crew, designed to literally suck the CO2 back out of the sky. So let's look at the planetary sunshade ideas, because this is where it gets really wild. There are proposals to basically copy a volcano by spraying sulfur particles into the high atmosphere to reflect sunlight. Then you've got even bigger ideas, like launching giant mirrors into space to block the sun, or sending out fleets of ships to spray seawater into the air to make clouds brighter so they reflect more heat. Now, the atmospheric cleanup approach is just as mind-bending. You have high-tech stuff like carbon capture, which grabs CO2 at a power plant before it gets out and then buries it deep underground. There are concepts for giant artificial trees that would chemically pull CO2 from the air. And there are nature-based ideas, like fertilizing the ocean with iron to create huge plankton blooms that would soak up carbon. But, and this is a really, really big but, here's the massive catch. As so many experts warn, with any of these planet hacking plans, it is pretty much impossible to know what all the long-term side effects would be. We'd essentially be running a giant experiment on the only home we have.
And these are not just vague what-if worries. We have pretty good reason to believe, for example, that the sulfur sunscreen idea could make acid rain worse or mess with the ozone layer. You could end up solving one problem only to create two more. It's like a game of planetary whack-a-mole.
And all of this leads us to the fundamental question at the heart of the whole debate. Are these incredible, high-risk technologies a necessary last resort we need to have in our back pocket? Or are they just a dangerous distraction from the one thing we know for a fact would work? Actually cutting our emissions and stopping our reliance on fossil fuels in the first place. That's the choice we're facing.